Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Modern. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of notes to review with everyone. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again later, or if you'd like to share this with the rest of your team, we will be sure to send you a link to the recording via email shortly after we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you have specific questions, we do want you to submit those to the Q&A box on the right side of that chat section. Sending your question to that Q&A box just helps us keep track of all of your questions. And we do have plenty of time set aside at the end of our session today to address all of your questions. So be sure to send those in. Additionally, we do have a poll that will launch a few slides into our program, so keep an eye out for that as it pops up. If you jump to the handout section, you'll see not only a copy of our presentation slides, but you'll also see some additional resources that Modern has provided for you. So please do grab those while you're here. And finally, we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible are to send in chats, send in questions, and to fill out our survey after the webinar. The link is in the handouts, and we'll also post it in the chat. So diving right into our topic, we're going to be discussing how to massively pay down your tech debt fast. I'm joined today by Pat Johnson, Head of Marketing at Modern, and we're also joined by Kevin Carpenter, Head of Engineering at Modern. So Pat, Kevin, thank you both so much for joining us today on Techstrong Learning. Pat, would you like to take over and lead us right into our presentation today?
Sure, thanks a lot, Cody. And thank you everyone for joining Kevin and me today as we take you through how to massively pay down your technical debt. For the next 40 minutes or so, try to set aside your existing paradigms for how you manage code maintenance, migrations, and security today, and just take in the exponential power of multi-repo mass scale refactoring with us. Also, as Cody mentioned, please be sure to ask your questions along the way and we'll try to get to them. So let's just jump right in. The growing impact of technical debt has become really the biggest obstacle to making changes to existing code bases. One report cites that technical debt is a $1.5 trillion problem in the US. And that same report also says that by 2025, 40% of IT budgets will be spent simply maintaining technical debt. So there's the technical debt that developers work on every day, and that's what you can see kind of at the top of the iceberg there with your penguin friends on running around. And then there's the debt under the surface. That's the deferred maintenance and upgrades, including older framework versions and that are reaching end of life, or security vulnerabilities that are just waiting to be exposed. These issues too often show up on a critical path for developers too, as a major migration project that could take months to complete, or an urgent remediation that's due to a security breach. And as you may have experienced, technical debt is expensive to maintain, and it comes at a significant opportunity cost for your business as well. It makes code harder to update and evolve, and much harder to build new, innovative features. It can also be a top contributor to why software modernization projects fail today. So what if you could migrate code in one app in just 10 minutes, making over 19,000 code changes? This was an actual example from a financial services customer of ours during their evaluation stage with Modern. We were able to automate their upgrade of a large training application to Java 17 in mere minutes. So that's what we're here to talk to you about today: how to eliminate technical debt at scale. We'll share a brief overview, including an introduction to our new Modern Dev Center dashboard. And then Kevin's going to dive into the key use cases of migration, analysis, and vulnerability remediation. And finally, we're going to close with just a little bit about the technology at work behind the scenes. All right, what does mass scale auto refactoring look like in practice? This is really what the Modern platform does every day. Our platform enables you to see your code base across repositories, and then we make accurate automated changes to the relevant files in those repos. So in this example, the Modern platform was focused on finding static analysis issues across 139 repos. We were able to automatically fix issues in 13,500 files in just over 4 minutes. And then a developer can review the diffs in our platform and do a mass commit. If this were developer spending, say, 3 to 5 minutes per issue, this would take around 75 days or 604 developer hours to complete all of those changes. This is what mass scale auto refactoring is about. And in a real world setting, this shows up as a significant boost in developer productivity. As an example, this mid-sized insurance company had over 20 million lines of code and 1,200 code repositories. They were averaging one large maintenance project per quarter. And each of those projects was consuming really the entire development team's effort and halting their feature work for a good chunk of that time. And you can see in that graph that in their Q2, they had a particularly onerous migration that took more time, and it resulted in fewer business stories being closed that quarter as well. But now their maintenance stories take a single developer and only part of a day using the Modern platform to update code and generate pull requests across all those repositories. In Q4, when the development organization showed an 1,100% increase in completed maintenance stories, their business partners were at first a little worried about, why aren't you focusing on new features? But then they were able to show that they're not only closing significant technical debt, but they also completed 30% more of the business stories than they normally did because they had saved so much time. So this customer did share 3 of their big wins from using our platform that I want to mention. First, they gained comprehensive, accurate visibility into their code base, including a better understanding of their transitive code health. The next, the automated transformations, they became the migration experts for their organization because these recipes of transformation hold the knowledge of prior software versions and the changes that must be made to upgrade. And then finally, they were able to run migration campaigns centrally across their code base, automatically updating code wherever there was a need with minimal developer disruption as well. So before we go on, we want to hear what your most pressing technical debt issues are. So let's take a quick poll. If you had to choose an issue you'd want to focus on right away, which would it be? Would you want to upgrade a framework that's reaching end of life? Would you want to know the full impact of breaking API changes? Or would you want to deal with unpatched security vulnerabilities? I know it's hard to choose among these 3. You may want to choose them all, but for our purposes, you need to pick one. So we'll give a few more seconds here. Let's see. Do we have the poll showing up? Yeah, sorry, I had to expand my screen. Ooh, interesting. All right, Kevin, what are you thinking about these results? And how does that align to what you hear from our customers too?
Yeah, this isn't super surprising. We've definitely heard it's different for every customer. They're all dealing with all 3 of these issues to some extent. We have several customers. Most of them are dealing with their unpatched security vulnerabilities every week, and this has been a big boon to them. But upgrading frameworks that are reaching end of life is the most common thing that customers reach out to us for to get started with to do at scale. So this is not surprising. The only thing I think that's surprising here, we actually have one customer that had that automated checking for breaking API changes using Modern. So every time somebody submits a pull request within their organization, they run a Modern auto refactoring check or an impact analysis to see where that's going to break. And then they have the opportunity to go tell all of those consumers of their application, hey, I'm breaking our API for you, so you can go change it. Or if it's a lot, they can write a custom refactoring recipe in order to go make that change for those consumers.
Yeah, that's very cool. All right, thank you. So at Modern, we want to help your teams tackle these hard technical debt problems. And yeah, there we go. We had to find the right slide. So, and we also want to drive substantive action across your organizations. And that's why we're really excited to announce the Modern Dev Center dashboard as part of our platform. This is a place where developers can collaborate to make code better all the time. And it's not just about the pretty graphs, it's also a call to action for every organization. So with the Dev Center, those months-long framework migrations can be a thing of the past. Instead, you can track the progress of software migrations and automatically upgrade lagging projects. This can be a major upgrade like the latest Spring Boot version, a migration from one technology to another, or even a migration to cloud-native tech. And instead of lengthy, expensive impact analysis efforts that can often be outdated by the time they're completed, with Modern, you can automate important data collections specific to your code base really fast, such as its dependency usage, say. And then you can analyze issues, understand the impact and the effort, as well as just stay aligned all the time. And instead of urgent security fixes that can consume your development teams for weeks on end, you can continuously keep an eye on your most critical security vulnerabilities. For us, of course, it's the OWASP top 10, but then you can readily identify your high-risk areas and fix the code immediately. Now I'm going to hand it over to Kevin to walk you through those tech debt use cases and demonstrate the power of mass scale auto refactoring. Go for it, Kevin.
Thanks, Pat. So you saw a screenshot here of the entire Dev Center. We're going to walk through each section individually and talk about the value, and then show a demo of how this works and how you can really run this at scale within your organization. So this section is for framework upgrades and migrations. This shows the current status of any of your migration goals, which can include framework upgrades like getting on the latest Spring Boot or JUnit, language version upgrades such as getting on the latest Java, and even a migration from one framework to another, such as migrating from Struts to Spring or Java EE to Spring. You can see this team of penguins huddled over here on the iceberg. And this, I really identify with this picture because it reminds me of any time I've had to, in my career, get together with my team, collaborate on how are we going to tackle this mountain, or in this case, iceberg. And this is just what you can see on the surface. As soon as you start digging in, there's a lot under the surface that you just hadn't accounted for. So it can just get really overwhelming. For instance, one migration can take thousands of steps. This diagram is the full migration to Spring Boot 3.2, which can take over 1,700 steps. This includes things as simple as updating properties to new formats, updating dependencies to new versions, to much more complicated things that require in-depth code changes like replacing constructors with factory methods. And this is why organizations fall behind on upgrades. It just gets too expensive and difficult to manage. So I think now we're going to go take a look at one example Dev Center. And just, I don't think I mentioned this yet, but we're using Spring Boot 3.2 here, but you don't actually have to upgrade to the latest version at any time. And because in order to upgrade to Spring Boot 3.2, you've got to update to Spring Boot 3.1 first, this migration actually chains to the migration before it. So the Spring Boot 3.2 upgrade includes the Spring Boot 3.1 upgrade, and that includes the Spring Boot 3.0, Spring Boot 3 upgrade. So you don't have to be on almost the latest in order to get to the latest. And that's why this has so many individual steps. And this is a diagram of that. And you can see this then chains down to another upgrade and so on. And we'll go into a little bit more detail about one specific example later.
But you don't have to go to the latest version either. You can
That's
go
right.
anywhere along that spectrum. Change.
That's right, Pat. We're if you are on Spring Boot 2.5 and you want to go to Spring Boot 2.6, we have a migration that will just get you to Spring Boot 2.6 if you're not ready to migrate to Spring Boot 3 yet. That's exactly right. Okay, so the view on Modern Dev Center, what we're looking at here is the Modern platform. The view on Modern Dev Center is of a specific organization, and throughout the rest of this presentation, I'm going to use the word organization to mean a team, department, company, really any group of developers and leaders that wants to see the status of and collaborate on their code base. And you can also think of an organization just as a group of source-controlled repositories that group of individuals, that group of people wants to collaborate on. So today I'm going to be showcasing the Modern Dev Center for the Open Rewrite codebase. Open Rewrite is the open source auto refactoring technology sponsored by Modern that runs at scale within our platform. So let's head over to the Dev Center. So this is the Dev Center for Open Rewrite. You can see that our framework goals include upgrading to Spring Boot 3.2, which you can see is complete, upgrading to JUnit 5, which you can see is complete, and upgrading to Java 21, which you can see is quite a ways from being complete. 86% of our repos are still on Java 8. And then we've got a smattering here on Java 11, a few on Java 17, and then a few that are already on Java 21. So let's see what it takes to get to Java 21. So I'm going to click this upgrade button. All right, so you can see across these 42 repositories, we have many changes that we're going to have to make. This will make change 36 repositories and change 1,000 files. So let's go look at some of these changes. So this actually hasn't made any change to the original source yet. This is just a recommended change, and then I'll show you after a bit how we can commit those results. So not only does the Java 21 upgrade get you onto the latest version of Java, so makes all the changes required to get you there, it also lets you take advantage of new features in Java 21. For instance, sequenced collections like lists in Java before Java 21, if you wanted to add at a specific index like the first or last, which would be the most common, you would have to specify that index. But in Java 21, you can just add first, get last. And then additionally, as I mentioned with Spring Boot 3.2, the Java 21 upgrade includes the Java 17 upgrade, which, just like Java 21, will include all new features of Java 17. So you can see down here, we're taking advantage of the instance of pattern matching to create a variable here that is of type Java type.parameterized instead of casting before using that to call getType here, which is only available on Java type.parameterized. And because there's so many steps, the Java 21 recipe specifically has 224 steps. I want to see which of those steps made this change. So I'm going to click these three dots at the top right, and then click why did this change? So just like I pointed out, we've got changes code to use Java 17's instance of pattern matching, which is part of the Java 17 migration, and replace list.get, add, and remove with sequence collection first and last methods. And so once you've reviewed through these changes, you can then come back here, select all, and commit at scale. And you can see doing this would commit these 36 results. And there's options to commit directly if that's your team's process. But most teams will create a pull request and submit that. I'm not going to do that here on Java 21, but I will do that a little bit later. So this shows you a little bit of how to manage your framework upgrades and migrations. So we would submit that commit, that would get merged, and then we would come back over here later and see, oh, now everything's on Java 21, done. So upgrades and migrations are part of the picture, but knowing what you have to do is a first step to being able to do it. So let's talk about impact analysis. Today's code bases are complex, and now with generative AI in the game, more code can be written more quickly. And what we're discovering from our large enterprise customers is they're finding it more difficult to get insight into the current state of their code. Leaders and teams have difficult but important questions they need answered on a regular basis, but those answers require expert research from generally senior engineers who also have a lot of feature work they've got to deliver. in order to resolve. Just the process of understanding can take many hours, and the data can be outdated by the time that you try to put it to use. What if you could visualize your code base in minutes? And that's where the visualization section of the Modern Dev Center comes into play. Visualizations, which are a feature of the Modern platform, allow you to see at a glance what might take hours of those research and scripting to accomplish. So let's go look at how this works in practice. So we see this visualization section here for the Open Rewrite codebase. Let's visualize our usage of Jackson modules across the Open Rewrite organization. And for those who aren't familiar, Jackson is the most popular serialization library for Java, used by Spring and other open source frameworks. And a mismatch in Jackson versions can lead across your code base can lead to serialization errors, and outdated versions of Jackson can lead to security vulnerabilities. More on that later. So you can see here across all of the Jackson modules that we have available, you can see their usage. The width of this file-in chart at each of these versions is how many places this dependency is pulled in within the code base. And then these are the versions, the y-axis are the versions. So just zooming in on Jackson core here, we can see that version 2.16.1 is pulled in 207 places across it as a dependency in 207 places across the Open Rewrite codebase. 2.16.2 for the Jackson core module is not pulled in at all, and 2.17.0 is pulled in 3 times. So this might indicate that, oh, we need to get these on the same version, or maybe it's okay. Maybe the repos that we have on 2.16.1 really require that, and that's okay. But this is the impact analysis you have to do first to determine whether you're going to have to make a change. So let's look at another example. We have one enterprise customer, for instance, who is a heavy user of Gradle, and they had trouble getting all of their teams on the same version of Gradle. So updating the Gradle and the Gradle wrapper allows teams to take advantage of security and performance improvements in Gradle. As part of this initiative to get every team onto the latest, they first had to do an impact analysis to see how far behind each team was. So let's take a look at Gradle wrapper usage across the Open Rewrite organization. Open Rewrite is also a very heavy user of Gradle. So you can see the vast majority are on version 8.7. We have a few still on 8.6, and then 1 or 2 here on 8.4. And so that gives you an impact analysis that tells you, well, what am I going to have to do? How far do I have to go to get on the latest? And how many people do I have? How many teams do I have to go talk to? Or there's also a migration to the latest Gradle wrapper that you can just submit, just like the Java 21 upgrade. So let's talk about security. The expectations on development teams just keep going up. We're used to have a single team dedicated to one application. One development team now manages several applications, especially with more things going to microservices and serverless. There's just like a lot more repositories per team, per organization. And even though the expectation on that team is deliver more feature work, more feature work, more feature work, that team is also responsible for making sure their applications are secure. The security section of the Modern Dev Center shows you a breakdown of the most important security priorities for your organization. So let's go look at it for the Open Rewrite organization. Okay, so our priorities for the Open Rewrite organization are making sure that we follow the OWASP Top 10 standard and a few other security. Oh, go ahead,
Kevin,
Pat.
sorry. I am still seeing your screen. I'm not seeing the
Yes.
demo. I'm not sure.
Thank you.
Okay.
Yeah, fixed.
There we are. Thanks.
Our priorities are making sure we follow the OWASP Top 10 standard and a few other security related recipes. So let's take a look at OWASP A1, broken access control. This looks at and fixes things like not meeting the principle of least privilege. So let's go ahead and we have 14 occurrences here. Let's run this and see what changes it makes. So we've got, you can see here, 14 results across 2 repositories, and let's actually go look at these. So we can see here this change that's being made, which I'll demonstrate the same way we did earlier. But these security recipes are very similar to upgrade and migrations in that they can potentially contain many individual steps. So if you want to see what specifically made this change, we can look at it the same way, clicking the 3 dots, and then why did this change? And this is fixing a partial path traversal vulnerability, which is a vulnerability inside Java that can be exercised if you do not specify that a path starts with another path. And it's important to mention that because we're looking at the Open Rewrite organization, which we are the sponsors of, these security vulnerabilities are only in tests, and they're specifically here for verifying that we can identify these that we can identify these security issues. So these cannot be exercised in production. It was important to say that and make sure that I demonstrate that to you all, that we are showing you Open Rewrite, but these aren't actual security vulnerabilities within Open Rewrite. But let's say I wanted to go fix these anyway. As you generally would, you would run this and then fix the results, submit those results back into your source control. So I'm going to do a commit here. And so I have everything selected. If all 42 of these repositories had changes, I would be committing all of them. Let's do it. And so I'm going to create a pull request because that's our process here. Create a specific branch. And then I'm just going to keep the default commit title, and that commit title will also be the pull request title. Obviously changeable, you can change all that, customize it. Let's go ahead and commit this. And this is going to push those changes back up to GitHub. I'm going to go ahead and leave this for now and go show a demo of another security recipe. So then we'll come back to this when this is finished. So back to the Dev Center. We additionally have a security recipe that will locate secrets stored in plain text in code. For instance, if somebody has somebody got a little bit what's the word I'm looking for? Impatient, and just decided to store their AWS access key in a file in the repository and then committed that and it made it in. Let's go ahead and run this to find secrets that are located in plain text in code. Okay, we found some. It's like 14 results like we had for the other one as well. Let's open Rewrite Java Security and look at these. So you can see here, this is an Azure access key that's been found in the source code. We also have a GitHub personal access token. We've got an Artifactory key. And this is useful for identifying and then telling your teams, hey, by the way, go figure out how to get this, go figure out how to get this key out of your code, please. Now, this is actually the test for the recipe that's doing this search. So these are not real keys. They are a real format for an Azure access key, for instance, but it's not a real key. But it absolutely could be inside your customer environments. And we found when running this within customer environments, occasionally we find some and they're like, okay, we're going to go fix that. So now we're going to go back to the activity view for Open Rewrite. This is a view of everything that's happening within your organization. So you've got recipe runs here. A whole bunch of recipe runs have been run. We've got commit jobs. So the one that we just did, that's what I'll open up. And even visualizations. So for things like you want to see, we looked at Gradle wrapper composition. I can go back to that visualization run. So let's go back to the commit that I just did. We can see that both of these are completed now. So I'm going to open this up. And now you can see this is actually back in GitHub. My name here on the pull request. If you want to rerun the security recipe, you can click this. We want to see the files that changed. We can see we're doing the partial path traversal fix here. And then if you look at the commit itself was made by me and then has Team Modern or automation as well. So every action taken within the Modern platform is taken on behalf of a user. A user is doing the thing, submitting the pull request, reviewing the results. It's all done on behalf of a user. So how does all of this work? What's the secret sauce? Well, there's one more thing I want to show you before we go into that. And that's dependency vulnerabilities and how you resolve the dependency vulnerabilities. So OWASP A6 here is designed, OWASP A6 here is designed to keep your dependencies up to date. But you can see that on Open Rewrite, we've done a pretty good job at keeping them up to date, and so there's no actual results here. So what I'm going to do now is show you an organization here within the Modern platform that does have results here. So let's go to the activity view again for the default organization. And we're going to run this find and fix vulnerable dependencies recipe. I'm going to go ahead and run it again, but I'm going to show you the results of the existing one. So I'm choosing this, reads through the GitHub Security Advisory database, which includes NVD and various other security vulnerability databases, identifies CVEs that GitHub Security Advisories as well that affect your code based on your dependencies. And then if their patch version can be updated, so if you're on 2.3.1 and there's a fix in 2.3.2, we'll automatically update you to 2.3.2. So I'm going to choose scope runtime and override transitives. So that'll give us the best, the widest scope. So this is compile plus everything that you have available at runtime. And we're going to override transitives. So if your dependence, if a vulnerable dependency is 2 levels down, we're going to override it in your repository. And that's useful if you don't have control over the repository in the middle, for instance, or if it's in a separate library that you don't have, there's not a fixed version for yet. So I'm going to go to the previous one of this that I ran. And we can see here, for instance, we have what do we have? 30 changed files, generally build.gradles or Maven POMs, across the 9 repositories that were changed. So let's look at some of these. So for instance here, we've updated to the latest version of Logback Classic and Logback Core. And that's like the only change that was made in here. You can also visualize these. So if you want to see across your entire organization, how many can actually be upgraded, how many require a minor version upgrade, how many require a major version upgrade, let's look at a visualization that was run on here. So across this default organization, these are the results. So we see about 400 that can be updated with a patch version upgrade, around 450 that can be updated with a minor version upgrade, and then you can also see this broken down by criticality. So you can see this percentage are critical. What is this? Critical. 20% are critical. 14% are moderate. 60% are high, and 6% are low. So this gives you a view. This one could also be shown in the Medern Dev Center. All right, so now let's talk about the technology behind the scenes here. What's the secret sauce here? Well, there's 3 major components that we want to highlight that allow us to make these large-scale upgrades and security fixes. The first one is the lossless semantic tree, which I'll be referring to as LST from here on, which you can think of as similar to an abstract syntax tree, but with a lot more information. So for instance, the lossless semantic tree contains all types in use across your application and all of its dependencies, as well as the full details of white space and comments to make sure that any changes made through this large-scale refactoring are accurate and preserve your peculiar style. The first step in the process is to parse your code and turn it into this format. And then we run open rewrite recipes and other auto-refactoring technologies, such as JavaScript code mods, on this LST representation of your code in order to do impact analysis and make automated changes. Open rewrite recipes are deterministic programs. You will be able to trust that these recipes will make accurate changes every time. These recipes use the visitor pattern to collect information and modify and replace nodes in the LST in order to recommend changes. And finally, in order to be able to run on your entire codebase at once, we distribute the work of running these refactoring technologies to worker nodes within our platform. Because some repositories are mono repos or otherwise just really big, have a ton of source code, a ton of elements, the entire LST is not guaranteed to fit in memory. To solve this, we deserialize fragments of the LST from disk, run the refactoring technology on each fragment, and serialize those results back out to disk. When the whole process finishes, we produce a patch from the edits made during this process. I highlighted, and I think it's really important to highlight again, that these recipes are generally deterministic programs because you need to be able to trust that the results coming out of here are accurate. That being said, and so for that reason, they're generally not using generative AI or anything to do these refactorings. We do, however, very much believe in the power of AI and what it can do for us. So I'm going to turn this over to Pat, who's going to talk about how we use AI within Medern.
Thanks, Kevin. So because of all of those foundational technologies that Kevin just talked about, Modern is able to integrate AI models very efficiently, cost effectively, and accurately within our platform in order to support this mass scale auto refactoring. So we're essentially going beyond an AI assistant in a single repo. It's AI reimagined for multi-repository work. We're currently bringing AI into our platform in a few different ways. First, we added AI to our search function to enable users to use natural language instead of exact match to discover recipes that could be helpful to them. Next, we've embedded calls to AI models within the recipes to do focused tasks. This way, the rules-based recipes are asking AI to assist with simple operations using specific context. And this makes the results more accurate and efficient. So we've also included a blog of this in the handout section for your reference. And the third pillar is where we'll leverage AI to review relevant subsets of code within the lossless semantic tree to diagnose issues in the code and recommend the right recipes that can fix those issues. These recommendations will be served up in the Modern Dev Center shortly, so stay tuned for this. And I just also want to mention that within the Modern platform, we're able to choose the best open source AI models for the task at hand. And your code does not have to leave our secure platform to leverage AI and get the work done.
Pat, I just wanted to ask real quick. You mentioned that in some recipes we use AI to make the results more accurate. Do you have a specific example that we can give for that?
Yeah, recently we did. We had a customer that had misencoded French characters in the code. And we generated a recipe that helped to discover the French in the code, and the AI helped to identify it as French language. And then we were able to replace that with actual real language. So the AI models that we leveraged a couple of different AI models to help with that work.
Nice.
All right, so I think that's all we have for you today. Really appreciate you all joining us. We're going to jump in and see what questions we have. I did see some coming in, but please access all of the resources we have for you within the webinar platform. There's a great article introducing the Modern Dev Center. We have a couple of customer case studies. We've got an ebook, more blogs, and a link to also our YouTube channel, which is a real wealth of tutorials, and I think you'll find that very helpful. We've also included a PDF of this presentation for your reference. Please go to our website as well, modern.io, to try out the platform, and be sure to follow us on our various social channels. The PDF file we attached has links to all of those social channels too. So now let's jump into questions, Kevin. Let's see what we've got here.
Sure. Okay. We talked about. Oh, sorry. Go ahead, Pat.
No, you go ahead.
I see the question. Is there a secure? I think I can publish this and then published is in a different tab. Okay, I see. Is there a secure save key function in platform? We don't have that yet, but there's really nothing preventing a recipe that would then you see this key is stored here, and then you send that recipe to something like a HashiCorp Vault or something like that, and you replace the reference in your code with the HashiCorp Vault instance. But no, that doesn't exist right now.
There's a question on our programming languages and what we support.
Sure. The question is, what programming languages do you support? You'll notice that all of our examples in the demo were Java-based, and that's because we definitely see a whole lot of Java out in the industry still. And additionally, the open source refactoring technology requires going really deep on each language. So we have a lot of Java, but we're also working on .NET support. We've got JavaScript code mod usage. We've even got the ability to run on Terraform and COBOL. So, and more being added all the time.
Do you want to respond? Can we create custom refactoring and migration recipes? Or not we, but can the person asking the question create custom recipes? Can you talk a bit about that and what support we have for that?
Absolutely. So these refactoring recipes are based on all the ones we showed are based on the Open Rewrite open source framework. And so all of our customers that we have written their own custom recipes that make changes based on their code instead of it. They use a whole bunch out of the box, but they all write their own custom ones that are not going to be, how do I phrase this, that are proprietary. So it's not specifically, you're not just limited to what is available out of the box in open source. You can write your own custom ones internally as well.
And we have a lot of examples and like refaster templates and things too that help create
Yes.
those. So how accurate are the changes that are made in the recipe? You mentioned accurate, I know, a couple of times. So can you talk to
Sure,
the
yeah.
accuracy?
So open rewrite recipes are written and tested on a whole bunch of code. So we have examples for every possible use case that we know of and can think of in the unit tests for the code. But then also we battle test these recipes. So every night we run recipes on thousands of repos, and we do that every time there's a new open rewrite release or a new release of our parsers, the parsers that actually turn your code into these LSTs, to verify that these are accurate. Now, that being said, these are programs written by people, and you have your own enterprise code that we've never seen before. It is definitely always possible that there's something we've never seen before. And so when that happens, you can either report an issue that, hey, this recipe is making a change that I didn't expect, and we'll fix that for you. Or you can commit a fix for it as well, since it's open source. I see the question, where is the analysis done? Your machines or mine? And this is a very good question. So there's actually a couple options. What you're looking at on the Modern platform here, this is being run on our machines in our cloud, on encrypted copy of the LSTs, made sure that if you disconnect your environment from our environment, we no longer have access to this. None of our engineers have access to any of this code, or even to log into your platform. But there is an option as well to run within your own environment and have none of that data leave your environment as well.
Yeah, that's an addition. We have the Modern DX edition that enables that kind of fully air-gapped environment for when you need that. And still get a lot of power of that auto refactoring at scale. How about this question? Why can't you just use AI to do the automated refactoring work? And frankly, it is on a single developer mode working within their IDEs. Everybody's using AI today. Why isn't that enough?
Yeah, that's a fantastic question. So we actually think of, so we use CodePilot internally, but we think of Copilot and other AI assistants as infinite interns. So you give a task to your interns bring you back results, and those results need to be reviewed by a human. They need to be tweaked. I use it frequently in my day-to-day work, but I probably accept something like 70% of those with changes. Pretty much all of them have to have some sort of change. So if you then extrapolate that out to making these changes in a platform, I like to use the cookie analogy. So refactoring results or good code it's like cookies, and the existing code are the ingredients to those cookies. If we've tried out actually using AI to take those ingredients and make the cookie, and what we found is it's right, depending on how good your input is, 50, 60, 70% of the time. That's not good enough for us. What we prefer to do instead is create a cookie cutter, test that cookie cutter across, tens of thousands of repositories, and then publish that cookie cutter. So Open Rewrite rules-based engine for programs, deterministic programs for making these changes.
The cookies are a lot more uniform.
Exactly. They're a lot more uniform, a lot more accurate, and a lot more likely to get through code review and not have problems when you deploy them.
Awesome. All right, what else?
I see a question. What is the oldest Java version that you can refactor? I believe the answer is we can refactor up to, or down to, I guess, Java 8 is the first Java that we have a parser for, but I believe that can parse pretty much any version of Java before that. So you can pull in, I believe, any version of Java and be able to refactor that onto the latest.
That's cool. Are all repos made available in GitHub?
That's a good question. If you're referring to, I'll publish that one and make that big. Are all repos made available in GitHub? If you're referring to the open rewrite recipes, these are open source, available in GitHub publicly. If you are working on, if you are a Modern customer and you have your own private repos, they're not for either your LSTs that you're generating code for and making changes to, or recipes. Those don't have to be public. The open rewrite recipes are Apache licensed. You are able to modify, change, do whatever you want, write new recipes on top of the framework. None of that has to be made public. All of that is still owned by you.
So Kevin, do you think there's how would you classify the learning curve for teams adopting Modern?
Good question. I have seen at most of our customers, a lot of them will be writing recipes. You know, some some of them were writing recipes before we even talked to them, and that's how they found us, and we're like, we want to run this at scale. But for people who are not haven't written them yet, we generally can. They watch a tutorial and they can be writing a recipe within an hour. To do the more complicated things, we have recipe writing workshops that we do with all of our customers, and there's some public tutorials as well for doing that. And so for the more complicated things, it can take a few hours of tinkering around with it to get exactly what you want for the first time. But yeah, it's good. It's quick. There's a great question that I want to make sure that I answer here.
Okay.
So if the code is running on your platform, is the code visible to your team? I think I covered this, but just in case, no. Nor anybody in our company can see your code, nor can we SSH into those boxes, nor can we log into your platform. We don't have any access to see your code. It's to us, it's ciphertext in our blob store. And you disconnect your environment from ours, and even you don't have access to that anymore, and it gets deleted. So I think that one was really important to answer.
Earliest version of Spring Boot that we can refactor. They have some 1.3. Let me just publish. Did it work? I don't think it worked. There it is.
You said 1.3.
That's the earliest version that this question said they have.
I'll have to go and find out the answer to that. The first one we can upgrade to is 2.0, so I believe we've got Spring Boot 1 to 2 from a few years ago that we wrote. That migration might have been the first one we wrote, was a Spring Boot 1 to 2 migration. So I believe 1.3 is fine. Another good question. Sridhar is asking some really in-depth questions, and I love it. Do we have to run it on demand, or can we set it to run automatically whenever we migrate code? So we recommend generally for anyone who is using the Modern platform to generate their LSTs, from their code on a regular basis. We recommend daily or on a schedule because we frequently make improvements to parsing as well. But the question of when you run the migration recipes or refactoring technologies, that's entirely up to you. So we have customers that run them every day and commit the results. We have customers that run them, manually once a week. We run certain things like the security vulnerability recipe. We run that automatically once a week and then submit a pull request for those changes. It's entirely up to you and how you want to use it.
This is specific to the Dev Center, but is it limited to used by developers, or can other members of a business team or security team be added to this, or how do they get access?
Yeah, that's a great question. So this is the dev center within each customer is configured by the central team that manages the Modern installation at that customer site, and it's configured per organization. And generally, the users of this dashboard are the leaders of that organization to know what the current state of the code is, and the developers themselves who are going to be doing the collaborating on the improvements of these numbers, let's say.
Do you want to talk a little bit about how we integrate or work with the CI/CD pipelines and DevOps workflows?
Sure, yeah. So specifically for CI/CD, um, well, okay. There's a couple different ways you can integrate with CI/CD. If you contribute to OpenRewrite, for instance, you'll see that when you submit the pull request, we actually run a set of recipes on your code and then suggest changes. That's one way that you can do it. I mentioned earlier we have a customer who verifies if they're breaking API changes every time somebody submits a pull request, and then it actually makes a comment on that pull request saying, "Hey, you're going to break a whole bunch of people." And then we actually recommend for generating these LSTs, we recommend that be a separate process that's not part of your CI/CD, and that's because there's constantly changes going out to parsers, and it lets you do it on a schedule that's not held back by compute on, say, GitHub Actions or your GitLab CI, things like that. We recommend that be a separate process that's just continuously generating new LSTs. And then the other way that is integrated is we recommend that everybody, when you submit pull requests from your code through the platform, that you run your own CI processes on that. You just guarantee that every pull request that gets submitted runs all your suite of tests and things like that. And that way you can verify that when you're creating a new recipe, that new recipe is going to work. And if it doesn't, it's not going to make it to production.
Great. Do you see any other questions in there?
I think I see a really interesting one here. So I'm going to publish this one. And man, I wish that. Okay. How do you recommend organizations prioritize which areas of technical debt to address first? And I don't necessarily have a specific, this is how I would recommend you do it. But what I would say is every team, every organization, every company has the things that are most painful to them. When people come to us, they're generally like, "Hey, I've been stuck on Java." We have one customer that's on Java 8 and is trying to get to Java 11. I've been stuck on this forever and I can't get teams to move. And that becomes their technical debt. We have others where the code quality is just bad, where they can, even now that with Modern, they can quantify what bad means and define it. Like they have SonarQube rules that SonarQube is telling them they've got a year's worth of work that they have to do to get out of tech debt. And so every organization has their own like pain points that they come to us with. I don't have a specific answer for you on how I would recommend that you prioritize which areas of tech debt to work through first, but generally the ones that are the most painful to you. And by you, I don't mean your leaders, I mean your organization, your developers who are hands on keyboard.
All right. That might be a good one to end on, Kevin.
Yeah, sounds good.
We're ready to close. All right. Thank you all for joining today. It's always great to get and share more about what we're doing at Modern. Take advantage of the handouts before you leave, and so that you can learn even more. Cody, do you want to wrap up for us?
Happy to. Pat, Kevin, thank you both so much for joining us today on Techstrong Learning. It's been such a pleasure hearing from you over this past hour. And we know how much time it takes out of your day to join us and share your expertise with us. So once again, thank you so much.
You're welcome.
Thanks, everybody.
So before I release our audience, just a couple of final remarks. The session was recorded and we will be sending it to you via email as soon as it becomes available. We'll also be publishing it on the Security Boulevard website. That is securityboulevard.com/webinars. We will be selecting 2 of our most engaged attendees today to win a $50 Amazon gift card. So thank you for your chats and for your comments. You'll see posted in the chat as well as in the handouts, there is a link to our survey. If you wouldn't mind filling that out for us, we would love to hear your feedback about this last hour. Any kind of pointers, we would love to hear them from you. I'd like to thank Modern for sponsoring this program today, and to everyone here, thank you so much for attending. We appreciate your time and we hope to see you at a future Techstrong learning experience. Have a great rest of your day and you may now disconnect. Thanks again, Pat and Kevin.
Thank you.
Thank you.